Alright, so this is the third in our videos for the review for the final exam. And in this part, it's really going to feel like test 3. So each part kind of feels like one of the tests we were doing. The directions here are find the increasing, decreasing intervals. So we know we are going to take the derivative, set it equal to 0, and make a chart. So let's start with just taking the derivative, which is x cubed plus x squared minus 12x. You should notice we're going to set this equal to 0, but they all have x's in them, so let's go ahead and take one x out. So now I have x on the outside, then times x squared plus x minus 12. I'm looking for factors of 12 that give me 1. So that's going to be positive 4 and negative 3. So I have 3 critical numbers. I have 0, I have 3, I have negative 4. So those 3 numbers go on my number line. So first negative 4, then 0, then 3, and then I can establish intervals. So negative infinity to negative 4, negative 4 to 0, 0 to 3, and I might just move that line over a little bit to give myself some more room, and we'll call this 3 to infinity. Okay. So we know once we have our intervals, we would like to pick a point in each one of those intervals. So let's say we pick negative 5, negative 1, positive 1, positive 4. We want to put these numbers into the derivative. So I'm putting it into x times x minus 3 times x plus 4. So negative 5 first, then negative 5 minus 3, which is negative. Negative 5 plus 4 is still negative. So this first interval, negative, 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 negative. That means decreasing. So we're going to do this 3 more times. Negative 1, negative. Negative 1 minus 3, still negative. Negative 1 plus 4, positive. So 2 negatives make a positive, and my second interval is increasing. Moving on to the 1, 1 is positive. 1 minus 3 is negative. 1 plus 4 is positive. This 1 negative makes the whole interval negative, so this is decreasing. The last interval, 4 is positive. 4 minus 3 is positive. 4 plus 4 is positive, so we are increasing. Number 25 is very similar in that we're looking for the increasing, decreasing interval. So we're going to start with the derivative. Because it's a natural log, I know the answer is a fraction. The x squared plus 1 will go in the denominator. The derivative of that, which is 2x, goes in the numerator. So when we look at fractions, we just need to look at the numerator, set that equal to 0. So I have 2x equals 0, which says x is 0. So once again, I make the number line, I put in the 0, and then I make my 2 little intervals. So let's say we pick negative 1 and 1 as our test points. And we're plugging that into 2x over x squared plus 1. And start with the negative 1. Negative 1 times 2 is negative. Negative 1 squared is 1. 1 and 1 is 2, so that's positive. This first one is negative, so this is decreasing. 2 times 1 positive, 1 squared plus 1 positive, so my second interval is positive, which is increasing. Right. So moving up from that, here's a word problem where I start you with the price P for which X items will sell is 12 minus 0.25x, and we want to get the revenue function. So my revenue function is 12 minus 0.25x times x. I think it looks better if you just go ahead and multiply the x through, so I have 12x minus 0.25x squared. Okay, noticing this is A, you know there's a B and a C and a D, whatever, where we're going to use this again, so might as well make it easy to start. Part B says find the marginal revenue when x is 10. So marginal means derivative, so we're going to start with the derivative. 12x is 12. The 0.25 times 2 is just 0.5x now. We want to plug 10 in. So I get 12 minus 0.5 times 10. That's just 7. Part C brings the cost in. So it says the cost is 17 over 4x squared minus 6x plus 100. We want to find the profit function. So P of x is R minus C. So my revenue, we said in the first step, was 12x minus 0.25x squared. And then I want to subtract the cost, 17 over 4x squared minus 6x plus 100. I don't want to leave this because, again, we're going to use this later. So I'm going to do a couple of things right away. I'm going to change this 17 over 4 into a decimal so I can combine it with the 0.25x squared. I'm also going to distribute this negative sign to all the terms in the second part so that I can see what can be put together. So I have a 12x. I have minus 0.25x squared. I have minus 17 over 4 is 4.25x squared. The minus with the negative 6 becomes positive 6x, and the minus with the 100 is negative 100. All right, so let's start kind of looking at like terms. I have a 12x and a 6x, so that's where I want to start. So 12x and 6x, that's going to give me 18x. Minus 0.25 with minus 4.25 is minus 4.5x squared. And the only thing we haven't used yet is the minus 100. So this is the profit function. The next part says, what is the marginal profit when x equals 2? So we found the profit. To get the marginal, we're going to take the derivative. That's 18 minus 2 times 4.5 is 9x. I'm going to plug in 2, p prime of 2, I have 18 minus 9 times 2, that's just 0. This really leads us to the question of how many items should be sold to maximize the revenue. Well, I hope it's 2, because right there we just found that the derivative is 0 at 2. And that's usually what we're doing. So we say 18 minus 9x equals 0. 18 is 9x, x is 2. So the 2 is good, we already knew that, but what you want to show is that this is indeed going to maximize the profit. So I want to take the second derivative. So 18 goes away, I get negative 9. Negative 9 as a second derivative tells me concavity. So getting this negative says this is concave down, and whatever extrema I have is going to be a max. Well, the only extrema we had was 2, so 2 is the number of items we should sell to maximize the revenue. 27 says the population of a city is growing according to the function p of t is a third of t cubed minus 7t squared plus 45t plus 1400, where t is time in years. When is the population decreasing? All right. So before I try to really figure that out, I say, well, I'm going to have to know the derivative. So a third times 3 just becomes t squared. The 7 times 2 is 14t, and then I have 45. So the 45t is just 45, the 1400 is gone. So I'm trying to find factors of 45 that give me 14. So that would be t minus 5 and t minus 9. So 9 times 5 is 45, 9 plus 5 gives me 14. So we set this equal to 0, we have 5, we have 9. I wrote 5 twice, sorry about that, let's fix that. So what we should be thinking about is, like anything else we've been doing that we're trying to find the increasing decreasing of, I do need to make a chart. So on the chart though, here's a big difference because we're talking about a population of a city. Time is positive. I'm not going to go back in time. I can only use from when they started. So this is going to start at 0. We have the 5, we have the 9, and it keeps going. So I know I have a 0 to 5, I have a 5 to 9, and I have 9 to infinity. So let's say I pick 1, let's say I pick 6, and let's pick 10. So these are the numbers that we're putting in to the derivative, and the derivative was t minus 5 times t minus 9. So 1 minus 5 is negative, 1 minus 9 is negative, negative, negative is positive, this is increasing. 6 minus 5 is positive, but 6 minus 9 is negative, so this is decreasing. 10 minus 5 is positive, 10 minus 9 is positive, this is increasing. So the answer, what we want is when is it in decreasing, it decreases from year 5 to year 9.